let's continue applying quadratic equations using applying them to real life situations. Okay? And so in this case, I'm going to give you a formula that is going to be used in a lot of these problems where they don't tell you what the formula is. You're going to have to find it yourself. So here's what the situation is. Okay? If we take an object and we either drop it, which means we just reach over the edge of a building or a cliff and we just let go and we don't put any speed behind it, we just kind of let it fall, right? That would be dropping. Okay? Or if we do throw it, right, we're putting some velocity behind it, we're putting some speed behind it as it's going up in the air, right, and then it's going to go up in the air and probably fall back down. That we can model the path of those objects in relation to time using this basic formula. Okay, h equals negative 16t squared plus vt plus s. Okay, this formula is assuming two things: that the time is represented in seconds and that the height is represented in feet. So those are the units that we're going to use. Okay, so each of these variables is going to represent something. H represents the height of the object. So again, we're throwing an object or dropping an object, and we want to know at any given point along its path from when we let go of the object till it hits the ground, okay, what height is it at? Okay, t represents time. So those are the things that are related. We're saying, okay, at 1 second it's at 50 feet, at 10 seconds it's at 75 feet, at 50 seconds it's at, right? So we're comparing the amount of time that's passed to the height of the object. Okay, v represents the velocity at release, right? So if we're throwing an object, it's going to maybe go leave our hand at 5 miles per hour or 10 feet per second or whatever the velocity is, which they'll tell us in the problem how fast it's going. Okay, and s represents the starting height. So it makes a difference if I'm standing on the ground when I throw the object or if I'm standing on top of the Empire State Building. So the s is going to tell us how high we are when we let go of the object. How high above the ground is the object when we let go? Okay, so there are 4 variables. They're going to tell us about a couple of them. Okay, they're going to have to tell us in the problem if they want us to write the equation. Okay, they're going to tell us what the velocity is, and they're going to tell us what the starting height is, and that's going to let us write an equation. And then they're either going to tell us how much time has passed so we can plug in for t, or they're going to tell us how much height the object is going to be at when we're trying to measure time, and we're going to be able to solve for t. So it's kind of like the last video that we did where it's either going to be providing us with time or providing us with height, and we'll have to find the other one. Okay, so the situation is going to fall into one of two categories. We're either going to drop an object, in which case the velocity of the object is 0. If we just let go, we're not putting any speed behind it. So we're going to plug a 0 in here, and this middle term is just going to go away. Okay, if it's thrown, they're going to actually say it was thrown at 50 feet per second or whatever the case is. Okay, so let's look at a problem, and this will make a lot of sense as we go. Okay, so the first problem is saying I'm standing on top of the Empire State Building. The Empire State Building is 443 meters tall. Okay, our units were in feet, so I'm just going to assume that this was feet. Okay, so we're going to plug in 443 for my starting height. Right, so if I was looking at this and they said, okay, you got to plug into this formula. Okay, h equals, well, let me pick a color that you can see. H equals, okay, negative 16 t squared plus vt plus s. Okay, so I'm going to go through this and I'm going to say, okay, I need to plug in for v and for s before I can answer their question. So in this case, they're telling me s. They're saying, here's how high you are, okay, when you're dropping the object. So I'm going to say s is equal to 443. So h equals negative 16t squared, and I know that s is 443 feet up. Okay, and now I'm going to look through my problem and I'm going to say, let's see, I need to find a speed or velocity. How much speed was this penny going when it left my hand? How fast was it going? Right, and in this case, I don't see that anywhere in the problem, but I do see this word, and it's telling me that I dropped the object. And we just said on the last slide that dropping the object means that you actually didn't add any speed to it at all. It was 0. So this is going to become 0t. Okay, I didn't add any speed to it, right? 0 times t. Okay, so what that's really effectively going to do, 0 times t is just 0, and that's going to go away. And my equation is going to look like this: negative 16t squared plus 443. Okay, and this is the equation that I'm going to use to answer their question. Okay, so what it's saying is I dropped the penny off the top of the Empire State Building, and I want to know how long is it going to take to reach the ground. So in this case, how long represents t. So they're kind of saying t is I don't know. Okay, and they're giving me the height that it's going to be, which is the ground. Okay, the ground is how high the penny is when we take our measurement, and the ground is 0 meters off the ground. Okay, so I'm going to say in this case 0 is my height because it's on the ground, okay, and I'm going to plug in and solve. Okay, and if you notice, no t value in the middle, which means I can just use the square root formula or the square root method to solve this problem. So I'm going to isolate t squared. I'm going to subtract 443 on both sides. Okay, so it's going to look like this, right? I subtracted the 443. I'm going to divide by negative 16 on both sides, right? So let's just go to our calculator to get some help with 443 divided by 16. Okay, so I'm going to say in this case, negative 443 divided by negative 16. So I'm just trying to isolate t squared. In this case, 27.6875. Okay, try not to round. The more you round, the less accurate your final answer will be. So I can write 4 decimal places, so I'm going to write all of them. Right? And now it's saying, okay, I want to know what t is, so it looks like I need to square root both sides. So my final answer for time, t is equal to the square root of 27.6875. So let me go and plug that in and hit the square root 20 of my answer. Okay, and the square root is 5.26. Okay, so I'm going to say time is 5.26 seconds. That's the answer to their question. How long did it take to reach the ground? It took 5.26 seconds. Okay, so we solved their problem. Okay, so let's take a look at another one. Okay, so the second problem, I'm going to do a magic trick. I'm going to go to the top of the Eiffel Tower, which is 324 meters tall. Okay, and I'm going to drop a watermelon. Okay, and then I'm going to run down the stairs, and I want to catch it exactly halfway down. So I'm going to reach my hands out exactly halfway down its fall. I'm going to grab it and I'm going to catch it. So I want to know how many seconds do I have to get down there and grab the watermelon. Okay, so again, let's think about the situation. Okay, I'm dropping the watermelon, right? So this is another drop situation, okay, which means v is equal to 0. Okay, I'm still 324 meters off the ground. Okay, so let's type in the or write the equation. The height of the watermelon is equal to negative 16 t squared. Remember, vt that was in the middle is gone, right? So I'm not even going to write that, and I'm 324 meters up. Okay, so I'm going to say this is my equation. V in the middle disappeared because velocity is 0 when I drop. Okay, so now the question is, I'm looking at this and I don't see any other numbers. So I'm kind of saying like, well, what do I got to plug in for? So I got to go through the problem and figure that out. So again, it says how many seconds, which means if they're telling me how many seconds, they're saying t is equal to what? So we don't know t. They're asking us about t. So they're saying, okay, the watermelon's going to be halfway down the Eiffel Tower. Well, halfway down the Eiffel Tower would be exactly half of where I started, right? So if I'm at 324 feet, half it would be 324 divided by 2, which is 162 feet. So I'm actually going to say exactly halfway down would be when h is equal to 162 feet. Okay, so I had to do a little bit more work in that problem. They didn't come out outright and tell me that I'm catching the watermelon at 162 meters. Okay, they didn't say that. I had to look at the problem and say I'm catching it at halfway. What is halfway? So a little bit more challenging in this one because I had to do that work. Okay, the solve is going to be exactly the same. So we're going to subtract the 324 over. We're going to try to get t squared alone. So I'm going to say in this case negative 162 is equal to negative 16t squared. Okay, I'm going to divide both sides by the negative 16 to try to get t squared alone. Okay, so we're going to say negative 162 divided by negative 16. It's going to be a little bit bigger than 10. Okay, so 10.125. And then I can square root on both sides. T squared's alone. So I'm going to say the square root of that number is about 3.2, 3.18 seconds, right? So we said that t squared was equal to 10.125. Okay, and when I square root both sides, okay, to get t alone, we just found out that t is equal to about 3.18 seconds for the object to get to about halfway, right? So this is using the drop model, we call it. We're dropping an object, velocity is 0, so that middle vt part of the general formula goes away, and then we just need to go find the information that they told us. In this case, the starting height was 324. Halfway, which is where I'm catching it, was 162, and I can plug in that information and solve for t.